and welcome back. This is the second part of the prerequisites chapter, section 2. We'll continue on with exponents, and we'll just dive right in. So the first thing we'll do is we'll see what happens when we raise a number to a power, and then furthermore raise that to another power. So we have some double exponentiation going on here. So here I've got b squared raised to the third power. So this means I'm going to take b squared times itself 3 times. And this would imply that I'm taking b times b times b times b times b times b, and we'll count 6 b's here. So this is b to the 6th power. And this will happen in general. If I take b to the nth power, for instance, and raise that to the nth power, I will have n copies of b. And the way that this works will be the same as up above. This will be b to the m times nth power. We've got n copies of b, so that's n times m copies of b. So let's use this to simplify some expressions. So here I've got 2 to the third power to the 4th power, and without having to write down 2 to the third power 4 times and count how many 2's there are, I know that there will be 2 to the 3 times 4th power, and 3 times 4 is 12. So this will be 2 to the 12th power, which I believe is something about 4,096. But I'd have to get a calculator out to check that. Here we've got x to the 2nd power to the negative 2nd power. Nothing changes. We're just going to take those exponents and we're going to multiply them together. So this is going to be x to the 2nd times negative 2nd power. 2 times negative 2 is negative 4. It's going to be x to the negative 4th power. And then lastly, again, nothing changes. We've just got a couple of negative exponents now. So this is going to be z to the negative 5th power times negative 1, and negative 5 times negative 1 is 5. We've got z to the 5th power. Now, in this next example, I've got 2 numbers in here that I'm raising to the 3rd power. And nothing strange goes on here, so we can just write this down. So anything to the 3rd power is just going to be itself times itself 3 times. So I've got 7y times 7y times 7y, and because we're only multiplying, and multiplication doesn't matter what order I do it in, I'm going to move the 3 7's out to the front, and I'll move the 3 y's to the back. So now I've got 3 7's, this is 7 to the 3rd power, and I've got 3 y's, which is y to the 3rd power. So what you'll notice is that you can distribute the 3 across addition. So in general, if I take a times b to the nth power, this is going to be the same thing as a to the nth power times b to the nth power. So again, I can apply this here. This is going to be the same thing. So I have negative 2 times y squared, and all of that to the 4th power. This is going to be the same thing as negative 2 to the 4th power times y squared to the 4th power. And then again, we can use our product rule. So y squared to the 4th power, this is going to be y to the 2 times 4th power. And then this first one, negative 2 to the 4th power, negative 2 times negative 2 times negative 2 times negative 2 will be 16. And then I can simplify the y to the 2nd times 4th power, which is going to be y to the 8th power. So we've simplified that. Okay. The one thing to notice is that you can extend this a lot further than just a product of 2 things. So for example, here I had just a times b to the nth power. So I only took 2 things and multiplied them together before raising it to a power. Here in this example, I've got 3 things. I've got 3 times x to the 5th times y, and all of that squared. Well, this works in exactly the same way. This is just going to be 3 squared, x to the 5th squared times y squared. And simplifying each of these, 3 squared is 9. X to the 5th power to the 2nd power, again, exponent to exponent, we multiply, so that's x to the 10th power, and y squared. The exact same thing happens for division, remembering that when we divide a by b, it's the same thing as taking a times 1 over b. So since division is the same thing as multiplication, we can apply the same rules to exponents. So this is going to be a to the nth power divided by b to the nth power. And just to demonstrate, I can take x to the 3rd power divided by x squared, divided by 2, and here this will be x to the 3rd power divided by 2 to the 3rd power, which is going to be 8. If I wanted to, I could do this a long way. And the long way works absolutely fine, but shorter ways are going to be helpful. If I wanted to take this, raise this to the 3rd power, I could take x over 2 times x over 2 times x over 2, and I've got 2 times 2 times 2 on the bottom, which is 8, and I've got x times x times x on the top, which is x cubed. So it doesn't matter how you do this. I think this way was a lot shorter and a lot easier. So when you are asked to simplify, remember that before when we saw that how to simplify algebraic expressions, we do everything in the exponents first so that we can get rid of them. We combine like terms, and we try to make the expression as simple as possible. Well, exponents, we can simplify exponents as well. And the idea is that we don't want any parentheses. It should be plural. We want to try to get rid of parentheses. Any powers raised to powers, we know how to deal with that. We just multiply the powers. Each base number occurs once. So in the expression b to the nth power, b here is the base of the exponent. So we only want each base to occur once in the expression. And we don't want negative exponents or zeros. Remember that pretty much anything raised to the 0 power is just 1, so that's pretty easy. And things with negative exponents, we flip what side of the fraction they're on. So, for instance, here, in this fraction, we don't want any base to appear more than once. So we see that we have an x to the negative 6th power and an x squared, and we don't want the x to appear more than once in here. So we'll end up having to simplify this a little bit. Also, there's a negative exponent on the x, and we don't want any negative exponents. So let's take care of this. My approach to this is to start to separate out all of the parts of this. We have the numbers, the coefficients of the term on the top and the term on the bottom. We can put that out front. I can take all the x's on top and all the x's on bottom and put them into one fraction. I've got all the y's on top and all the y's on bottom, put that into a fraction. All of the z's on top and all of the z's on the bottom. There aren't any z's on the bottom, so we just write z divided by 1 here. And if you notice, if you take all of the numerators and you multiply them together, we get what we started with. And if you take all the denominators and multiply them together, we get what we started with. This means we're on the right track. So let's start simplifying this. 6 divided by negative 3 is going to be negative 2. Here we have a couple of exponents being divided. We know that we subtract exponents when we divide. So this is going to be x to the 2nd power minus negative 6. Here we have a y divided by y. So this is going to be y to the 1st power minus 1. And here I've just got z. Anything divided by itself is just, anything divided by 1 is just itself. So simplifying this is going to be negative 2. X to the 2 minus negative 6, well, that's x to the 8th power. 2 minus negative 6, the negatives cancel out. 2 plus 6 is 8. Y to the 1 minus 1 power, well, 1 minus 1 is 0, and anything to the 0 power is just 1. So this is negative 2 times x to the 8th power times 1 times z here at the end. But if we multiply something by 1, it doesn't change. So this is negative 2 times x to the 8th power, I should draw a better 8, times z. Okay, let's go through one more example. Here we've got a fraction raised to a power. What I will do is I'll take the top raised to the power and the bottom raised to the power. So this will be 4 to the negative 2nd power, and then the bottom, which is x to the negative 1, y to the 3rd power, all of this raised to the negative 2nd power. But again, for this bottom, I've got two things that I'm multiplying together, and they're both raised to a power, so I can raise them both to that individual power. So this is going to be x to the negative 1 to the negative 2nd power, y to the 3rd power raised to the negative 2nd power. I can start to simplify a couple of these. X to the negative 1 to the negative 2, we multiply exponents, so this will become x to the negative 1 times negative 2 is 2nd power. And y to the 3rd to the negative 2nd power, if we multiply these, this is y to the negative 6th power. And then ultimately, anything with a negative exponent, we flip what side of the fraction it's on. So the x squared stays on the bottom. The 4 to the negative 2nd flips over and becomes 4 to the 2nd power on the bottom. And the y to the negative 6th power flips to the top and becomes y to the 6th power. Again, 4 squared is 16, so we might as well simplify that. 16x squared. So here is your simplest version. And I will stop there. There will be one more part after this.